All right, so the next thing you're going to have to be able to do is take a z-value and find an x score for that known z-value. Remember, z-values go under the standard curve, but the mean is understood to be 0 and the standard deviation is 1. But when we have real world situations, you have like here the veterinarian records for the weights of cats. It's normally distributed, so it fits on this curve with a mean of 9. So what they're giving us right there is an x value, and we know that that x value is 9, so 9 is the mean. It's going to go right there, and a standard deviation of 2 pounds. So one standard deviation away, we're going to be at 11 pounds. 2 standard deviations away, we're going to be at 13 pounds. 3 standard deviations away, we're going to be at 15 pounds. 1 standard deviation on the light side would be 7 pounds. This would be 5 pounds, and this would be 3 pounds. So there's the x values for each one of those. A z-score of 1.96, that's going to be almost at 2. Okay, so we know that z-value is going to be somewhere a little bit shy of 13 pounds. So I'm going to guess 12 point something pounds. But guessing is not good enough. We want an x value for that z-value of 1.96. So if you take this formula that we have right here and you do a little algebra to it, you multiply both sides by the standard deviation, and then you add the mean to get the x by itself, this is the formula that you get. So for problem number 1 right here, we can find the x value simply by taking the mean, and the mean here was 9 pounds and the standard deviation was 2. So you just plug in all the numbers. The mean is 9 pounds plus the standard deviation, which is 2 times your z-score, 1.96. So you just simply do that math, and that'll give you an x value that corresponds to that z value of 1.96. So what's going to be the weight of the cat that is 1.96 standard deviations away from the score? The cat is going to weigh 9 plus 2 times 1.96. The cat is going to weigh 12.92 pounds. What is going to be the weight of a cat that is a negative 0.44 standard deviations away? Well, negative 0.44, that's a little less than a half. So I'm going to guess that this is about the z-value of negative 0.44. Okay, and so that's going to correspond down here to something less than 9 but bigger than 7, so 8 point something pounds. So x is going to equal to 9 plus the standard deviation times the z-value, 0.44. So the cat that is negative 0.44 standard deviations away from the mean of 9 is going to weigh 9 plus 2 times negative 0.44 is going to weigh 8.12 pounds. 8.12. So this value right there is 8.12. That 8.12 corresponds or will have the same area as the negative 0.44. This one right here was 12.92. That corresponds with the 1.96. Oh goodness, that should be 1.96. 1.96 does come out to be 1.92. Okay, and then the third one, again, this one should not have to be calculated. If the z is 0, then the x value is 9, because 9 is the mean. So if z is 0, we're talking about the 9. Okay, so that is that question, and that's pretty much what you have to do with this next value right down here. I am gonna, oh, here it is. Gotta find myself. Here are the two problems. I am gonna go ahead and stop this video right here. I know it's a little bit shorter than normal, but why don't you try to see if you can't set this one up? You're gonna start by, I'll probably cut and paste a picture over here, but draw a standard deviation curve, put the z values on there, and then underneath it draw an x, and see if you can't figure out, what the picture looks like that goes with this story situation.